Okay, let's take a look at this chemical reaction here. This is attaching the enthalpy to the mass of reactant when we do a chemical reaction. So what I have here is this: 1 mole of methane is burned at constant pressure. Remember, this pressure here is kept constant so we don't have to deal with W of energy, and 890 kilojoules a mole of energy is released as heat. Let's first write this out. So we have CH4, combustion is with O2. So we've got O2, and then that is going to produce H2O plus CO2. And then all good chemists are going to balance their equation here. All right, and we see that it's a 1 to 1 to 2 to 1 ratio. Okay, oh, and plus constant, and 890 kilojoules per mole of energy is released. So because this is being released, it's going to be part of the products, 890 kilojoules. Okay, so we can treat this just like any other stoichiometric problem, but now instead of having moles or grams of product, we're going to have kilojoules of energy. Okay, so what we start off with is 5.8 gram sample of methane, so 5.8 grams, and I'm going to convert this into moles, all right, because we're dealing with moles here, we're dealing with quantities, and methane is CH4, so we're going to round that to 16 grams of CH4, and that equals 1 mole of CH4. Now, I want to make this this clear here. This is an easy one because it's a 1 to 1 to 2 to 1 to 890. We're going to create, we still need to use the coefficients here, okay? So if this was a 2 here, I'd be putting a 2 moles of CH4 to 890 kilojoules. But I don't have to do that because this is 1. But just know that when we're doing these problems, we're still using the coefficient in front of our reactants, okay, to determine what the ratio is to products, except this is just a different ratio. In this case, it's 1 mole of CH4 to 890 kilojoules. Okay, we just have a different product that we just haven't seen before. All right, and then we follow the same conventions of 5.8 times 1 times 890, and then we divide by our denominators. In this case, it's 16. So this is 320 kilojoules. I did round this to 3 sig figs, okay, because of this 5.8 value that we were given. Actually, this is in 2 sig figs. I'm sorry, this is 2 sig figs. We don't have a decimal there. Okay, 2 sig figs and 2 sig figs. So 320 kilojoules. Okay, and that's how we relate this to a reaction and the equation. Please, 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 please write this out. It helps so much in being able to see what is going on.